All right, so I'm just going to show you how to quickly set up a table. This isn't a formal table, but I mean, if you wanted to, you could, oh, table one, just to show you how this works. Table one, confused. Table one, valuation, variance, ratio, test. And then this would be the legend. So we'd merge that left, up, and wrap text. Merge this guy. Merge this guy. And then just add in your underlying line functions, for example. And do any other kind of formatting that we want. We might want to get these guys in center. Or we might want to decrease the number of decimal points. Things look a little bit more realistic on everything. All right, and then a table like this, you would then do like a Control C on the copy, and then I'm just going to dump it in here, and then a Control V to paste. And this is the way you put a table into your actual write-up. And the idea here is to be able to, if I update my data, I'll rerun the analysis and then generate new statistics, and therefore my table automatically updates. All right, so here we've just set it equal to the JSTAT tab. Here we just enter the values. This is NQ for our analysis, which is just the N that we have. The Z statistic. And this statistic here is coming from the paper. So you can see here that the square root of NQ times the JR is distributed as a mean zero variance of 2 times Q minus 1. If we take the square root of the variance and divide it onto the other side, where it's standard normal distribution, that's what they're talking about down here. And therefore we can just do a straight test on it. So over here I'm just using 1 minus the norm distribution as a cumulative function, and that's telling me that my p-value is 8% here, 0 here, 0.17 here, and 70% here. This last number seems a little bit odd to me, to be honest with you. I didn't see anything wrong in the code. When I originally did this is the results that I ended up with. And they're actually exactly identical to what's in the text of the paper. So I'm probably thinking we just got a data adjustment issue here that's going on. So anyway, I have no problem with your number should end up being exactly the same as my numbers if you're doing it the right way. And that's how you create a table in Excel by exporting out of SAS. It's a lot easier doing that kind of copy and paste. Cutting and pasting, it's easier to format the table. If you want to change things, you can just grab a whole column, move it out of the way. If you want to do like a reorder, let's say I want my NQ. Not sure why we're having a problem here. So I might want to get my NQ, for example, and move it above my Q value. I don't know what's going on here. So I just drag this one down and then highlight. So it must be like both of these guys are highlighted for some reason. And then we're just going to move this guy back over. So I mean, those are just some examples of why it's a lot easier in Excel to do all the modifications. And I'm not sure what's going on between these two tables. So I'm just going to exit that, let me just, in fact, I'm just going to go ahead and close this guy off. Don't need it anymore. All right, so we've done our first one. Next thing is, as it says here, we're going to go to an overlapping variable and then generate our end statistics, and then our end distributions are testable via this. And you can use either one. I prefer the bottom one because we've gotten rid of this sigma 04 taken care of. Anyway, so this is the next step that we're going to do. We come in the SAS. I've already, it's just busy work to type it in, but basically we want overlapping. So it's in this case it's going to be 1 plus 2, and then 2 plus 3, 3 plus 4, etc. So we're going to have overlapping variables associated with everything, and we'll go ahead here and run the code. These lags are not the missing variables, or because I'm trying to do lag 15. I can't do that until I'm on the 16th observation, and then go from there. All right, so that's why we're getting some missing variables. This variables proc AG. Make sure we're in the right spot here. Here we go. It just means progressive aggregation. And you can see where these missing values are being generated. All right, so we have our numbers that have been created. Our next step is to go and get our variances. My variable is work return, and then NP2, NP4, NP8, and NP16. So proc means no print. Change our var def to n. The var is work rtrn, and then our output, if I could type correctly. So out equals v par 1 or p var 1. What do I got wrong here? I need my data statement. Proc means, there we go. All right, so that's our first one. This is going to be our second one. Then we're going to do our NP2. And then there we go. And I don't need a mean on this one, just the variance. And we're set up. So we'll do a Control C. Now we're going to go to 4. That's 2. And then our 8. And then finally our 16. So those are all of our variances that we're going to be interested in. Okay. And then just a quick run. Check the output. That looks good. All right, we got a little bit of additional work that we need to do here for our variance adjustment. So we have to use our M variable here and make an adjustment in terms of the positioning of everything in order to do the overall calculation. All right, so back to our SAS. pvar2, set pvar2, and then we'll just take a quick look. Here's pvar2, right? We have a frequency and we have the actual variance of this rolling calculation. So now we're going to do our adjustment to it. So RTRN2var is going to be equal to RTRN2var times frequency divided by the quantity of 2 times quantity of FREQ underscore minus 1 multiplied by parenthesis multiplied by the quantity of 1 minus 2 divided by semicolon. All right, and that's this adjustment that you see in here, okay? Make this adjustment to the value of the variance. We're adjusting it in this way to accommodate for the fact that we have serial correlation in the system. So we may need to make this variance adjustment. All right, and then we'll need to do that for each one of the variables. Control C. So now we're going to go into 4, and then we need the adjustment here. 3, make sure I'm right. Yep. And then we need 4 here. Again, this is why you need to understand and read the paper carefully. I'm not going to spend a lot of time showing where each one of these valuations come from. That's what you need to be able to do in your process. So I just got to pay attention to my editing here so I don't muck it up a little bit. Alright, so now we need 8. And then we're going to go to 7. And then 8. And finally our last one. So this is our 16. Got a muck up here 2. This should be a parenthesis. All right, make sure that our parentheses are balanced. Yes, yes. Yes, 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 yes. All right, so all of our adjustments should be made. Excellent. Now we just go back and calculate all of our T statistics. Set it merge 3. Merge pvar 1, pvar 2, pvar 3, pvar 4, pvar 8, pvar 16. So those are all of our merges. And then our MD2 is going to be RTRN 2var minus RTRN var. And our MD4 our RTRN 4var minus our RTRN var. MD8 RTRN 8var minus RTRN var, and then MD16 is our RTRN 16 minus RTRN var. And then we have our MR statistics, which are probably the easier ones to do the calculation on. So MR2 is going to be my ratio, RTRN 2var divided by RTRN var minus 1, MR4 RTRN 4var divided by RTRN var minus 1, and MR8 equals RTRN 8var divided by RTRN var minus 1, and so we've done all our calculations. Now we're ready to do a proc export. I'm just going to grab this guy again. And we're going to change this sheet from JSTAT to MSTAT. So we're going to the exact same file. We're just going to adjust the variable that we're going to be interested in evaluating, or we're going to change the sheet, is what I meant to say. So then we'll just go ahead. Gotta make sure the file that I want to export to has to be, it can't be open. So I just wanted to make sure that that was the case. Let's go ahead and save this, do a run. So our export went out okay, 1 observation, 15 variables. We can open up our results now, and here's our M statistics that we have in here. And then I'm just going to go back to my original document. So these are the original MSTATs that we got for 2, 4, and 16. This is our theta stat, which we'll have to work on here a little bit. And then what the actual Z-stat of the system was. And then we can go ahead and create the Z-score distribution that we're interested in. In other words, what the p-value is going to be. All right, so we've gotten through 2/3 of the analysis. We have our M statistics that have been output, and we can run the actual M test if we want. There's one more component to everything, so that's theorem 2. We can do our underlying distribution, make the adjustments. This was the standard deviation, so it's NQMR divided by our standard deviation becomes a 0, 1 mean. This is what you're looking at right here. And then we can do our z-test directly from it. All right, the next thing we need to do is our heteroscedasticity increments. So in this case, what we want to do is apply this final section, calculate our different deltas, and then do the overall z-score. So you'll see this is the z-score that we're going to be looking for. So what I'm going to do right now is go ahead and stop the video. I've got some typing to do to go ahead and complete just the underlying process, and we'll go from there. There's one little trick that I want to use here, and that'll be the last thing I'm really going to show you, and I'll let you guys finish it. The rest of it's just kind of process related. All right, thanks a lot. Bye.